When was the last time you went to a presentation? These other questions you can only ask.
Who are we again as an audience?
You are civil engineers with one or two supervisors. They're supervisors.
Yeah, I'm a supervisor.
Okay. Okay, I want to tell you today about a new piece of software that I've seen recently. It was a stress analysis for civil structures software, but with a new way to have input to it. This is with a graphic input rather than the alphanumeric input. I'm going to talk about the advantages of this new graphic input method. By comparison with the current methods of using alphanumeric, its entry is much better. It has an ease of operation, and it will also let you people become familiar with a new technology. We have tested this software, the newest version of it, and we found out that it operates quite well. And the latest, the work that Sherman Park has done with it is also proven very well. There is a course coming up that will be offered in-house, and I'm recommending for you to take this course of operating this graphic software. I'll be covering three aspects of the software. One which would be the ease of input, the input of data into the software. The second one would be revision of to existing stress models, and the third one, the advantages of producing reports and presentations out of this software results. Well, as I said, it's very easy to input data into graphics screen compared to entering data into an alphanumeric table. In an alphanumeric table, you are dealing with lists of numbers. You don't really see whether what you're entering represents exactly the building. Whereas in graphics, you point to beginning and end of a column, and you see the column that you're replacing. Similarly, you see beams, and they're color-coded so you can tell which is which. Also, you have icons, those little pictures that you see at each end of members, which represent the cross-section of the steel member, whether it's an I-beam or a channel or an angle, and also you can tell the orientation, whether you have put it correctly or not. In addition to it, you have a graphic entry of loads. Here you have a floor loading these beams, and you see the distributed load that's associated with that floor, and you see graphically how it's distributed and also its magnitude, how big it is. And here there is an example of a concentrated load that might represent a piece of equipment sitting right at this point. You have nodal points for which you get computational results, and you can tell where you need more of them, where the stresses and forces are changing rapidly, and you need more detail of that area. And here for the restraints of the model for the stress analysis, you see also special graphic symbols to show how much the members are restrained, such as whether they're anchored, or whether they're free to spin but not to move, and so on. And with this mode of input, you can reach much higher productivity because it's much quicker compared to the alphanumeric way. You are less likely to make errors because you see what you're doing. You're dealing with things that are closer to the real object rather than numbers that are more abstract.
Does it have a library of all these channels and numbers beams?
Yes, there is.
Do you have to input the characteristics?
No, there is a standard, like the steel book that you have as a book is entered by the supplier of the software, which is Intergraph. And you just recall some of the steel that you require into the screen.
So
So then what about wood?
Yeah, okay, but wood this is already a different question. Wood does not appear in catalogs. It's altogether in a anisotropic material, and there is a whole subject to itself that I can direct you to some literature about.
Question. When you select a point on the screen with a cursor, whatever, right, and you associate a certain number with that point, where is the point and the number are stored in the computer?
Well, they are stored on the disk of the computer, and you're getting there into more the technical part of how computer works.
You mean you have a database? And,
yes, but this is all hidden from the user. The user doesn't know how it's done.
But the user can have access in that database and modify it?
Yes, they can do it, but it's the average user will not do that. The average user will. This will be something done by a troubleshooter rather than a.
But you can have an output of this database at any time.
Yes.
To go on Anna Maria's question, does your database only carry steel, or does it carry other metal members like aluminum?
The database allows you to define new materials, new cross-section members. You can have an aluminum steel, but there is no standard catalog for aluminum beams and columns that is in place. You would have to build one yourself.
Why couldn't you do it with wood?
You could do it with wood, only wood is a totally different kind of material. As I said, it's anisotropic. It doesn't bend both ways the same way because of the fibers.
When you open your graphic file, you start working at a later time. At the same time, the database is open, the associated database is open together with the graphic file.
Yes, they are completely linked.
So whatever you do, any change that later on, the database is aware of that.
That's right. So these are really the inner workings of this software, and it's if you want more material on it, I'll direct you to the proper manuals, which are not really user manuals, are already technical manuals of how the software is
This is what
constructed.
database is relational.
Hey, quit it! I want to hear more of his presentation.
Again, you'll find this in the manual. Shut up.
It's not a good way of answering
software
questions.
integrate with the drafting the CADs? The
Yes,
CAD
this
system,
is
it's part of it?
in fact, this is a part of the basic drafting software. It's built upon the foundations of the drafting software.
So you can actually design, draw, and at the same time analyze your.
That's true. It's all integrated. Now a little more about results that come out of this software. No, I'm sorry, I have to. I want to talk first on the revision of the models. The stress models can be easily revised. This is a great advantage. During the design procedure, you have many times change of design that comes from the project or from the project office or from the civil engineer himself, where you want to make changes in your building. This is quite easy in graphics because you're dealing with symbols of objects rather than numbers. You say, I want to move this column from here to there, rather than say X is now 20 meters instead of 22 meters, which is much more abstract. So dealing with these actual pictures, you can very easily revise the model, and then you, literally by the push of the button, you resubmit it for analysis. This allows you, excuse me, this allows you to go through many iterations and trials of different analyses, and thus you can find a better solution, a more optimal solution for your structure. You're encouraged really to look for a better one because it's so easy. In Sheridan Park, they've gone through 3 cycles of redesign of the steel inside the reactor building, and I doubt that they would be able to do it if they had done it through alphanumeric, the more traditional way of entering data. once the analysis is complete, it's quite easy to understand the results of the analysis because they are graphic too. You can look at your model, which would be color coded according to whether a member in your building has passed or failed the analysis as per code requirements. You can also see a deformed shape of the building, which gives you an idea where the problem areas are and where you can add more stiffness so the building does not deflect as much as it does. So it's with just looking at it, you'll see immediately where the problem is compared to a list of numbers that, let's say, the 10 highest deflection. If you look at the table, I'm sure you would much prefer to ask yourself where is the red or where it's failing, rather what are the 10 highest deflections.
Why would I want to use this instead of Stardyne?
Stardyne is a mature product. I agree with you that Stardyne has proven itself. Only it's missing the graphic interface.
But you can always get the graphic interface attached to it.
As far as I know, there is no graphic interface to Stardyne. Stardyne you require to enter it in alphanumeric.
Oh, okay, that way. But
yeah.
I understand Stardyne has a lot more flexibility than the program that you have.
Yes,
and it's much more. It can do much more different types of analysis.
That's true that Stardyne is more mature and therefore it has more options. Only for our task that we have in front of us, this does very well those options. They are, by the way, being developed now by Intergraph, and they will be delivered as updates to the software in the future. So when we do need them, they will be available.
What's a typical time frame between your entry of the data and the answers you get?
It depends a lot on the size of the building, because it's usually cubed. If you have 3 times as many nodes, those brown circles, it's 27 times longer to analyze. That's true for any software graphic.